Innovation begins with discovery, and discovery is driven by advanced research infrastructure. My name is Shahid Salim. I'm an associate professor in the Department of Mechanical Engineering, and currently I'm involved in research in friction, wear and lubrication, tribology for short. I'm currently the chairman of the Central Research Facility Center, CRFC, at NIT Srinagar. This CRFC is a multidisciplinary research hub providing state-of-the-art characterization, testing, and advanced material coating fabrication facilities for researchers and industries and academic institutions of the country in general and of the region in particular. Our mission is to create a world-class research ecosystem that enables innovation, promotes interdisciplinary collaboration, and supports high-quality research addressing national and global challenges. This center basically was set up as a vision of Professor M.F. Vani around 10 years back. This facility center has received funding from the Ministry of Education under various initiatives like PMDP, TCube3, and other institutional grants. The objective was to establish a world-class infrastructure which would be accessible to most of the education institutions within the UT of J&K and also in the region. Specifically, we have University of Kashmir next to us, we have SCOST, we have Institute of Medical Sciences, and we have IUST, we have SMVDU. With most of these institutions, we have collaborative work, and obviously there is scholars and the students make use of this facility regularly. If we look at the vision that we look to what CRFC is going to have in the future, our vision is to establish this center as a leading research and innovation center in the region and a nationally recognized lab or hub for advanced scientific instrumentation. Our aim is to continuously strengthen our infrastructure and also propose cutting-edge research projects. We welcome researchers, academic institutions, and industries to partner with us in advancing innovation in science and technology. The doors of CRFC Center are always open to everyone. Together, we can build solutions that contribute to a sustainable and technologically advanced future. I thank you for your attention. Thank you.
We have this equipment and we can determine elemental compositions of various samples, such as we have solid samples, we have powder samples, we have liquid samples, and even thin films. So what we do, we determine the elemental compositions ranging from beryllium to uranium, beryllium being the lightest element and uranium being the heaviest element. So we have two types of chambers installed in this equipment. One is called vacuum chamber, which is used to determine the elemental compositions of solid samples, and if we have to analyze liquid samples, for that purpose we use a separate chamber called as helium chamber. Now what happens when X-rays fall on sample? The sample emits secondary X-rays or fluorescent X-rays, which are then determined the different types of crystals used in this equipment, and then we determine the elemental composition of that sample. This equipment works on Bragg's law. This we have here is Raman Spectroscopy by Renisha. This famous equipment is based on Raman scattering, which was discovered by a famous Indian scientist called C.V. Raman. This equipment provides us the chemical composition, crystal structure, and molecular structure of various elements, of various materials. We have here is a 532 nanometer wavelength laser, which provides us various analysis of materials. If we talk about the laser power, the maximum laser power we can set on this equipment is 50 milliwatt. This equipment is widely used in pharmaceutical industries, in mining industries, and in semiconductor as well as battery research. Film banyak tayar. Film. Is 1 hour film.
So this model is integrated with the energy dispersive spectroscopy and electron backscattered diffraction detectors. FESEM, we already know that it will enable us to have high resolution image at nanoscales and microscales. The resolution of this instrument is 0.2 nanometer with the magnification ranging from 65x to 5 million. With the integration of EDS, we can perform elemental mapping, quantitative compositional contrast. With the help of this machine, we can perform analysis of both biological and non-biological samples as well. We can test materials at their nanoscale, or we can test the biological samples. The only criteria here is that our sample should be completely dry. Otherwise, we can have any sort of information from any sort of sample that we want to test. We can test morphology and topographical analysis of the samples. And one more thing, that EBSD that we are having right now is Velocity Pro model, and the EBS integration that we are having right now is Octane Elect Plus. They are top tier in their segments.
Electron TI Premier nanomechanical system. It is used to determine the nanomechanical properties of materials, primarily thin films, coatings, and nanomaterials. So it has basically three modes: nano indentation, nano scratch, and nano wear. So in all the three cases, we usually use a very sharp indenter, which is a diamond indenter. Some of the examples are Berkovich tip. So this system is capable of measuring normal force, normal displacement, lateral force, and lateral displacement with nanoscale precision. So we can determine properties like hardness, modulus, creep, fracture toughness, wear resistance, and even tribological properties like wear resistance and coefficient of friction.
Hi there, I welcome you all to the lubricant testing lab at CRFC NIT Srinagar. In this particular lab, what we do is we actually study the flow behavior, the stability, physical stability, and the thermal stability of the lubricants. As we all know, lubricants are used to reduce the friction in any moving or mating parts inside the machinery or any other components. So what we do here in this lab is actually we study the behavior of those lubricants under different or varying ambient conditions. One of the key instruments that is present in this lab is the rheometer. Rheometer is used to study the flow behavior, the stress behavior, as well as other rheological properties of the lubricants. Since lubricants operate under various operating conditions, so we need to determine the feasibility as well as the suitability of those lubricants under those working conditions. And one of the most important aspects of the lubricants that needs to be studied is their flow behavior as well as their stability under different operating conditions. So that's where the rheometer actually comes into play. It studies the flow behavior of the lubricants under different stress conditions, under different temperatures, under different ambient conditions. The next instrument that we have here in this lab is a particle analyzer. A particle analyzer is actually an instrument that is used to study the stability both at the particular level or at the atomic level of the lubricants. Not only lubricants, in general any fluid. So if you have any fluid and you have actually mixed any nanoparticles or some other additives into it, and you want to see what is the average particle size distribution of those solute particles within that solution or within that fluid, you can do that with the help of a particle analyzer. It is also used to actually determine the electrical stability or the ionic stability of the particles within the mixture. That defines how it operates in the actual scenario. Then the third instrument that is pivotal in the research of the lubricants is the flashpoint tester. So what we actually mean by flashpoint is actually the lowest temperature at which the vapor of a particular fluid like a lubricant or a fuel ignites or catches fire. So what that helps us to determine is the thermal stability of a given lubricant or a fuel or any other fluid that is under study. So we determine the thermal stability and the safety or handling of the lubricants or the fuel that we are actually analyzing using this flashpoint tester. So in short, in this lab, the lubricant testing lab, it's not actually limited to only lubricants. This lab, you can study the behavior of any fluid, whether it is a lubricant, whether it is a fuel or any other additive fluid. So in this lab, what we do is we study the flow behavior, the yielding stress of the fluids under different stress conditions or deformation conditions, as well as their physical stability, their particulate size, their molecular weight, their calorific value, their flash point temperatures, and their thermal as well as physical stability. Hi there, I welcome you all to the X-ray diffraction lab, which is commonly also known as XRD. XRD is a XRD is actually a very powerful and most widely used material characterization techniques in material science. What happens in XRD is that X-rays interact with the atoms in a sample and they actually give us coded information about the then depending upon how those X-rays interact with the atoms within that sample, it actually helps us to determine what kind of a sample we are dealing with. The main or the core principle of XRD is based on Bragg's law. What happens in Bragg's law is it studies how the X-rays diffract at specific angles from within the atoms of the sample, which is also dependent upon the planar distance of the atomic planes within the crystal. So depending upon the interplanar distance of the atomic planes within the crystal and the atomic arrangement within that sample, the X-rays get diffracted at different angles. Then the diffraction pattern of those X-rays actually acts as a unique fingerprint to the material, which then helps us to determine what kind of crystalline structure or what kind of compounds or elements are present within that sample. If we talk about the applications of the XRD, they range from from pharmaceuticals to polymer industries to nanoparticle industries, FMCG sector, etc. All in all, each and every of these sectors use or incorporate XRD in one or the other way. The most promising aspect of this particular instrument is that we can determine the crystal structure of the material at the atomic level without actually destroying the sample or the material that we are analyzing. Depending upon the applications of this machine, it is used for phase analysis. Phase analysis helps us to determine what kind of crystal structure or what kind of compounds are present within the sample that we are analyzing. It is also used for crystallinity analysis. In crystallinity analysis, we are actually able to distinguish between the crystalline and amorphous substances. Apart from that, XRD is also used to determine the lattice parameters, to determine the grain size, to determine the texture, the residual stresses that are present within the material, as well as the preferred orientation of the grains which are present inside the material. So in short, we can say that XRD, the main advantage of using XRD for material analysis or material characterization is that it is a non-destructive technique of material analysis, and we can do both qualitative as well as quantitative analysis using this instrument.
This is an atomic force microscope. This particular equipment is manufactured by Bruker. and the model is dimension XR. This particular instrument is used for imaging of materials at atomistic level. So atomic force microscope dimension XR is capable of doing the topography and mechanical property mapping and liquid imaging, conductive AFM. We can also do scanning capacitance microscopy, we can do scanning tunneling microscopy, we can do MFM, we can do KPFM. We have almost all the modes in this particular instrument. This AFM has a stage size of 200 millimeter chuck size, and where we can place the bigger size silicon wafers also. The scanner in this AFM is tube scanner, which is a very efficient and reliable scanner. And in addition to this instrument can record the images at 8000 by 8000 pixels with stitching and 4000 by 4000 pixels without stitching.
So at CRFC NIT Srinagar, we have a Magnetron sputtering machine, which is by Moorfield Nanotechnology UK. Specifically, the machine is Mini Lab 060 model number. The thing is, we have the Magnetron sputtering having 2 RF and 1 DC PSUs. And the thing is, we use this machine to carry out research in the fields of aerospace, bioengineering, tribology, etc. We use this machine to create pure nanoscale thin film coatings, whether they can be metallic, non-metallic. Regarding the machine, we have 2 chambers. One is the process chamber and the other is the load lock chamber. We carry out the coatings in the process chamber. We have 3 PSUs, 1 DC and 2 RF. The machine is capable of going down up to 10 to the power minus 7 millibar base pressures. We do coatings using pure argon, and we are also able to do coatings using oxygen and nitrogen as reactive gases. So we can either create pure coatings, and we can also create nitrides and oxides using nitrogen and oxygen.
So we also have a laser texturing machine at CRFC. About this machine, we have 2 heads, 1064 nanometer wavelength head and a 532 nanometer wavelength head. We use this machine to carry out research in the fields of, again, aerospace, bioengineering, tribology, environmental engineering, etc. We use this machine to create complex and intricate designs on sample surfaces. For example, we use this machine to create micro size dimples on substrates for use in tribology. This machine, that's the laser surface texturing machine, including the Magnetron sputtering machine. It comes under the surface development. So these 2 machines we have that we can use for surface engineering and like in material development. So again, this machine has 2 heads, 552 nanometer wavelength laser and the 1064 nanometer wavelength laser heads. The 1064 is capable of going up to 20 watts high beam power, and the 552 nanometer wavelength is capable of going up to 5 watts high beam power. And regarding the spot size, both the lasers are capable of going. They are actually capable of doing spot sizes between 5 microns and 30 microns. Regarding the pulse duration, both the laser heads, they are nanosecond. laser.
My name is Dr. Muhammad Nadeem Bhatt. I am working as Scientific cum Technical Officer in Central Research Facility Srinagar of National Institute of Technology, Srinagar. My research expertise is solidification of metals and alloys and their characterization. Central Research Facility Center of this institute was established in 2012 to cater to researchers within and outside the institute. Users from different academic institutes and industries enjoy the benefits of these research and testing facilities. CRFC houses various high-end sophisticated characterization and testing facilities catering to material science and engineering, physics, chemistry, environmental studies, energy studies, and industrial applications. For compositional characterization, we have WDXRF, we have Raman Spectrometer, we have EDS, we have GCMS, and we have CHNS analyzer. For atomic and microstructural characterization, we have field emission scanning electron microscope, we have atomic force microscope, and we have X-ray diffractometer. For texture studies, we have electron backscattered diffraction. For high temperature testing of materials, we have high temperature and cryo setup vacuum tribometer. For the development and testing of nanocoatings, we have multi-target Magnetron sputtering system and nanomechanical system. In addition to these, we have other high-end sophisticated research and testing facilities like flashpoint tester, particle size analyzer, TGA DSC, and 3-axis laser texturing system. At CRFC, all the equipments are regularly maintained and calibrated and are operated by highly skilled engineers. By virtue of advanced instrumentation and technical expertise, we provide consultancy services to various departments and industries like JSW, NHPC, CPWD, JK LCMA, R&B, Jal Shakti, and Anti-Corruption Bureau, and many more. Researchers from across the country can easily access our facilities through iSTEM portal or just by visiting our website. Thank you very much.